Hello, welcome to Marsh Mathematics, and in this video I'm going to be looking at points of inflection. Okay, so in this video I'm just going to talk through all the information you need to know about points of inflection. Now it's quite a lot of information, so I'm just going to talk through it now. Okay, there are two types of points of inflection. There are stationary points of inflection and non-stationary points of inflection. And I'll just go through with a green pen and just highlight all the different sections. So a classic example of a stationary point of inflection, this one here, okay, is when we have y equals x cubed. As we differentiate it there, we get 3x squared, and at x equals 0 here, we get dy by dx equals 0, and then we differentiate it again to get d2y by dx squared, and we substitute x equals 0, we get d2y by dx squared is equal to 0 as well. Okay, now remember, for a maximum d2y by dx squared is going to be less than 0, and for a minimum d2y by dx squared is greater than 0, so it's equal to 0, so it's not a maximum or a minimum. Okay, it's a point of inflection, and that's how it's defined. Okay, and if you look, which is really important here, so we found that before, if you look before 0, okay, well, this part of the curve, you'll find that dy by dx is greater than 0, but d2y by dx squared is less than 0. And look, for the other side of the curve, when x is greater than 0, dy by dx is greater than 0, and d2y by dx squared is greater than 0. So what you notice, okay, these 2 points, that dy by dx does not change sign, but d2y by dx squared does change sign. Now for all points of inflection that is true. Okay, so these are the two things that you need to remember. Now a non-stationary point of inflection is when, if you look over on this side, is when dy by dx is not equal to 0. That's why it's called non-stationary. Stationary means dy by dx equals 0. Okay, but if you've got a maximum, we've got a maximum here and a minimum here, okay, then you'll find directly in between the maximum and minimum, you'll find that d2y by dx squared is equal to 0, because before this point here, this is a concave downwards, okay, or concave. This section of the curve is concave, and therefore d2y by dx squared is less than 0. But if you go to this section of the curve, which is like a minimum, d2y by dx squared is greater than 0. So in between, it's equal to 0, and that's what makes it a point of inflection. Okay, but the important thing is that dy by dx is not equal to 0. You can see it's not equal to 0 either side. It's less than 0 either side. Okay, so that is the main thing to remember, that in point of inflection, okay, d2y by dx squared is equal to 0, but it's only for a stationary point of inflection that dy by dx is equal to 0. For a non-stationary, dy by dx is not equal to 0. But in both cases, right, either side, for a stationary and non-stationary, okay, dy by dx does not change sign, but d2y by dx squared changes sign. Now this is important when we come to questions, answering questions. In the next video I'll be looking at answering questions, and so really this is a good set for me. This summarizes everything you need to know about it. Okay, now there is an exception that they may or may not ask you. You know, it does come up, and it's a classic where y equals this one here, where y equals x to the power of 4. If you differentiate it, you get 4x cubed, and put x equals 0 in at this point here, right? And we get dy by dx is equal to 0. So it's a stationary point. Then when we differentiate it again, and we get 12x squared, we put x equals 0, and we get d2y by dx squared is equal to 0. And everybody's going to think, right, it's a point of inflection. But it's not a point of inflection. Why? Because dy, it doesn't obey these two rules here. Dy by dx is less than 0 on this side and then greater than 0 on that side. And also d2y by dx squared does not change, because you can see that it doesn't change because it's actually a minimum. d2y by dx squared is greater than 0 on both sides. Okay, so it is not a point of inflection. It's not a stationary point of inflection. It's actually a minimum point. Okay, so just because, and this is the thing that you could get in a question, just because d2y by dx squared is equal to 0 doesn't mean to prove that it is a point of inflection. It must obey these two rules here, because y equals x to the power of 4, the quartic equation, gives us an exception to that rule. Okay, so just be careful with that. Now, in the next video, I'll be looking at a couple of examples on stationary points of inflection and non-stationary points of inflection.